You want to talk about it?
So if we have like 13.5, like what's the range going to be allowed?
Oh, awesome. No, good question. So this being a homework worksheet, it's a little bit less specific than, say, an AP test. So the AP test won't do that to you. Like, they'll draw a graph, and they'll make sure that if you have to read the graph, they'll either have clues in the wording, or the graph will be so specific you won't have any doubt as to what you should be picking, or it'll be multiple choice, those kinds of things. So you don't need to worry. This was just me kind of drawing it up, so no, it's not perfect, but good question. 2 points for Sage. Anybody else? So nicely done. The particle is at rest whenever the velocity is 0, and the particle changes direction when the velocity changes from positive to negative or vice versa. Okay, item C takes a little bit more discussion, so I'm going to record it just so we have it on the website for those who need to go back and watch it again. They say that at time equal 3, the particle is at location 3 meters. So if I were to draw a picture of that, let's see, we call location 0 the origin. So here we go, the particle is maybe here. This is at location 3, and right now the time is 0. And then it says, is the particle moving away or towards the origin at time equal 8? The key idea is that, now, hopefully this comes as like feeling pretty straightforward, common sense. From time 0 until time 8, just say it out loud please, is the particle moving right, left, or both?
Right.
Right. From time 0 until time 8, every velocity of the particle is a positive value. So the particle is strictly moving to the right. Questions? So that means the particle started here and it moved some amount to the right. Okay? How much, I don't know exactly, but at time equal 8, the particle is somewhere over here. So the particle is to the right of the origin. And at that moment, at time equal 8, is the particle still going right, going left, or stopped? Say it. Still going to the right. So you know that the particle is moving away from the origin, and that's your justification. Like, that's what you have to write. Question. That's the answer to C.
Would going to the left be wherever it's negative on the x-axis or on the y-axis?
It's perfect. During this time period, the particle is moving this direction to the left. So,
because
yes, please.
So if we're like here at first and then switch positive,
Listen to Eli's question. So you said if the particle had started over here somewhere?
so like it's going left, so the velocity is negative at first.
Oh, so like it starts here.
Yeah.
If the particle, I think I got what you, everyone watch this. The particle starts here and it's moving to the left. The problem becomes a lot more complex because I have to figure out a way to figure out, well, where is the particle at time 8? For example, if I can figure out that the particle is here at time 8 and it still has a negative velocity, say it out loud. Is the particle moving towards or away from the origin? Louder? I'm getting a mix here. So one more time. What he's asking is, the particle starts, he's making up a new problem, just anticipating the future. The particle starts here. The particle has negative velocity, so it is moving left. So at this moment, is the particle moving away or towards the origin? Towards. At this moment, it's moving towards the origin because origin is location 0. Everybody with me? Okay. I'd have to figure out where is the particle at time 8. If the particle is here at time 8, now I need to know the velocity at that time. If the velocity is negative, I'm going to go towards the origin, but if the velocity has switched to positive, I would be moving away. Another possibility is, I start here, I have negative velocity, I move all the way to here. Now I look at the velocity, and if the velocity is still negative, I'd be moving away from the origin. Other comments or questions? This will get tested on the next test, so this idea of away and towards. It's really pretty simple if you just remember. If they ask whether the particle is moving towards or away from the origin, you need two pieces of information to answer the question. You have to know where is the particle located and what is the velocity at that time. And then you can figure out whether the particle is moving away or towards the origin. You need me to talk through that again. Awesome, cool. Okay, 9D says, use a right Riemann sum with 3 subintervals indicated by the data in the table to approximate this integral. So everybody do that, go.
So how do you know what the date is? Like, do you always do whatever D0 do you know how it's going to be like D0?
It's a D.
Yeah, I know, so I was just saying, like,
Oh, so for the switch, you get 8. So this one would
so from 0 to 3. Oh,
so this would be the 20 and 12.
Yeah, because I got the answer.
So you got
this one has 8 pieces.
Who has an answer? You get negative 120. And the units would be?
Meters.
Okay, a couple things too for Brecken. Look up. All eyes here, everybody look. A couple warnings. You're prepping for the next test, which is a written test, as well as, of course, the AP test, which half is written. Most people are used to classes where the grading is done pretty quickly. Like the teacher does not look super close just because they can't. It just takes far too long. I can't grade that way. The next test gets graded very, very carefully. The way I do it actually is I invite students who want extra credit to stay after school for like 2 hours. And the test you take, you won't put your name on it. You'll just put your student number, so no one knows whose test it is. And then each student in the room gets like 5 tests, and we go through each question like super carefully, because the AP graders are going to do the same. And so things to watch out for. Just as I walked through, I noticed a couple of things. Look here. You've got to get this notation right. Like I saw some people doing this. They write integral equals. That's kind of like writing plus equals. Like it doesn't mean anything. Like this symbol all by itself doesn't mean anything. Just like plus by itself doesn't mean anything. So don't do that. It's got to be the integral 0 to 25 of the velocity times dt. Okay? Next thing to watch out for. As always in this class, don't do work, think as you work. So check. You're supposed to be taking velocity and multiplying by time. So the velocity is in meters per second. So let's see, meters per second. The change in time would be measured in seconds. So when those two multiply, the result is meters That makes sense. That's what I'm trying to figure out. When I integrate velocity, I'm finding a change in position. So that's confirmation to me that I'm doing something that makes sense. Questions? Please.
Are we allowed to abbreviate to the 5 parentheses 8 on the test, or do we have to be like the 5 meters over seconds?
2 points. When they say include correct units, the only place they check the units is the final answer. So you don't have to show units along the way. Is that what you meant?
Yeah.
2 points.
That top equation, do we have to show that?
To get all the points on a test question, mine or the AP test, if your computation, if you're computing an integral, you must show the integral because they often give points for it. In this case, because it says show computation, you have to show either this green line or this green line. You don't have to show both. You can show both, you don't have to. Is that your question, Bella? 2 points. Please, Luke.
If we have the velocity versus time, and we're trying to find the position, is this like the reverse of like a derivative?
Everybody look at me. This is really good. Look. Okay. I like to think of Danica's chart. Here's why. We're talking about velocity and position here. So we'll use S to represent position. And you already all know that if you take the derivative of position, so you have a formula for position. If you find the derivative of that formula, you get the formula for velocity. That's depicted in Danica's chart. What Luke is saying, which is a very good observation, if I go this direction, I'm now integrating instead of differentiating. You don't actually get the formula for position. So you don't get a position. What you find is a change in the position. So it's not a perfectly symmetrical relationship, but there is symmetry for sure. Question? Cool. Okay, another thing I've seen people do wrong, look up here. We are going to compute this integral, and the method we're using to compute the integral is a Riemann sum. So don't do this. The integral isn't equal to an integral. The integral is equal to this series of computations, the multiply, 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 and then sum them together. So don't put that. Questions? Please, Jack.
So what does the negative 120 meters mean? Because that's some displacement, right?
Uh-huh.
Position. Does that mean
Talking.
it went to the left of the origin?
Oh, close, not quite.
Or it has to be.
2 points for Jack. Everyone look. Come on, look up. Okay. When you integrate velocity, you are calculating displacement, change in position. So this is my, and these are estimates because it's a Riemann estimate. But this is saying that in those 8 seconds, the particle displaced 40 to the right. Then during these 12 seconds, the particle displaced 120 that way. So nothing to do with the origin necessarily. That depends on where the particle started. But definitely I am displacing to the right, now displacing to the left for 12 seconds, now back to the right. I'm sorry, back to more to the left for the next 5 seconds. And so in total, I'm saying that during these 25 seconds, wherever I was, I have displaced that way.
Okay.
Does that answer your question? 2 points. There you go. Awesome. Okay, we're going to move to a different problem. I'll let you finish this one as part of the homework. So stop that.